Does it work now? I think now it works. Give it a few seconds. You see here, I see basically it's supposed to work. Yes, supposed to. Yes, now you see, now it should work. Is that right? I think it should work. Okay, good. Okay, so again, here magic command, the question mark, you get the documentation. It is, however, maybe a little bit cumbersome to make sense of the text from time to time. So read it slowly is my advice, right? Play around with the function a little bit. And try to focus on the things that are very clear, right? And very clear here is create a new string object. From a given object means, or you pass in object 888, right? Get a string back, right? Okay, so we can create several string objects, no problem. So here we have string of 4, string 2.0, string 1.9. What's happening here? We get S3 and we get them back. And then we ask actually what is type of 4 and what is type of S1. And we see here, when we use 4, it will be integer because it's the simplest data type Python can assume here. But if we pass S1, which is our string 1, which has the information 4, but as a string, the data type is string. So far, so good. Question, right? So what's the sum of S1 plus S2 plus S3? So when you go above and see the values of 4 to 1.9, so the result is 7.9 when mistaken, because here the sum is for the concatenation of strings, meaning put the string together. So the result is 4, 2, 0.0, 1.9, all put together. We did this last time to format the time of a day, right? With date and minutes. We use the print function to do this. You can do this here with a string concatenation as well. We can actually do this live action exercise. So the hour is what? It's 10 o'clock. The minute is what? 20. And now I can say my string format is string age plus the colon as a string plus the minute plus what you would AM, PM, minutes, hours, maybe AM, right? Plus string AM. That should work. Equal sign thing. So I just missed the value assignment of M. Can fix. What's going on? I forgot to convert M to a string. No problem. There we go. The string is 10:20 AM. So far, so good. Okay. Yes, now finally the factory function. We encounter list. So list is one of the more important data objects in Python that you will encounter frequently when you go to the numerical computation. We will replace them with arrays, right? But for basic Python, lists are quite handy. So what's a list? A list is a collection of objects that can have different lengths and different data types, which makes it a very, very flexible tool. Let's see, can we put a magic symbol on this one? Yes. If no argument is execute, let me see or what's in the list. So 1 property of the list is it's actually indicated by a square bracket. Previously, I highlighted round brackets. Remember, round brackets were used for function definitions and function calls. Print, for example, used a round bracket. My sum used a round bracket. Here we use square brackets because it's a collection of values. Let's see. What can we do with this? So we can, for example, say that my list equals 1, 99, 2, 98. So far, so good. So we assign the list to a variable my list, and then we can call what is in my list. 1, 99, 2, 98. So far, so good. We can mix the data types a little bit, so we can add a dog, a monkey, and a bird. Okay, no problem. So in this list, we have now mixed data types, right? We have integers, we have strings. We can mix them with floats, right? So we see here type is integer, integer, float. How can I convince you that this is really a float? Well, besides that you see it's 2.0, we can ask a list for all the elements of the list, but for a particular element. How do we do this? We use the square brackets again. Right? So you see square brackets are quite handy for lists. Now let's put 0 here, right? That would be the first element at index 0. We had a similar notation when we played around with the strings. We can, okay, so the first element, right, gives me the value 1. Then I go to the second element, index 1. I get 99. So I can go to third element, index 2. That is 2.0. I can ask for the type. What will I see? Float, right? Yes, float. Good. Now let's see what this can we do. Let's select the dog, okay? So my list dog is where? So this is 0, 1, 2, 3, 4. So we go to 4. That should be the dog. But dog itself is a list of characters, right? So we actually can, let's say, select the G. So G is at 0, 1, 2. Sorry, 2. Okay? So because a list can be hierarchical, right? I can select the list, and within the list, I can select a new list. Let's see what we can do. So we can my list equals, well, 1, let's say new, and my list. I execute, or that works. That works. That works. Let's see what I got. Do you remember what an iteration is? So the iteration is when I do something over and over again. So what I did just now is like, I say I create a new list, which is my old list, and a new element new. It's a new list. And then I store that in the object of the old list. And then I do this again and again and again. So whatever we see now here is quite a nested list. Right? You see there's 1, 2, 3 new. And this is my old list here, right? So how do I select, for example, monkey now? What do I do? You try, okay? So what do I do to select monkey? Let's see. Be careful with the bracket, reads them as you do in the matroshkas, in the Russian nesting, right? You open one, right, and then you select, right, and select the next one. Let's see. So when I have here my list 0, I get new on my list 1. So this is this part here, right? And the command on the same hierarchy, on the same level, lives all of this one, right? That's another one of these dogs. Can you see now the difference between my list and my list? Select the second element. We select this second element, right? Now to do this again, right, we can either select the first element, which is just new, or we select the second element, which is the next level down, right? And then we do this again. And finally, we are at the level of our initial list, and now we count, right? 0, 1, 2, 3, 4, 5. Did we say monkey or bird? Which one did we want to select? Bird? Monkey? Anyhow, no, I say monkey, right? So 1, 2, 3, 4, what? 0, 1, 2, 3, 5, right? Is it 5? Yeah, finally I select my monkey. So far, so good. So what have you seen here is list collects data. Data can be anything, right? No restriction. And we can nest data, right? List into list into list. So it can be quite complicated. And we can select elements of any of these levels of the list through the so-called indexing notation using square brackets. So far, so good, right? Okay. Now, sets are a little bit different from lists. And sets are very, very useful because they are basically inspired from mathematical sets, right? Where you have like a set A and a set B, and then you form the difference, the intersection, the union. And one property of the set is there are no repeated elements. Right? There's also some. Okay, let's play around with sets a little bit. So for set 1, 2, 3, 4. We must pass a list to this function. Good. So what you observe first is, this uses curly brackets. So sets, list, and function all use different brackets. Round brackets, square brackets, and now curly brackets. So in our list, we have the values 1, 2, 3, 4. Let's copy them, duplicate them a few times. Right? So we have now everything double and triple and quadruple times. We execute, and we still get only unique elements. So suppose you have a list of students, right, that come to your class. And some student enroll 2 times, 3 times because they like it so much. then you pass that list of students to a set, right? The set filters out all the double enrollments, and you get a list of students that actually come. It's really, really easy. So if, for example, right, we want to define a function filter, so duplicates, right? We would get my list. Go here, and we just need to return a list, so of set of my list. Done. So what does it do? It basically takes, let's say, what can I do here? It's one of these common tasks in data science when you clean your data sheets from duplicate entries. Right? Some data is recorded twice. You don't want this in your evaluation. So you would just whatever data you have, pass it to filter duplicates. But you don't want to work with a set, you want to work with a list, right? Because for some reason it's easier. And you have a list back with non-duplicate values. Let's see, does it work for mixed data as well? So it works with strings as well, right? So if two students have the same name, for example, also get filtered. So far, so good. So why do I give you this example? When I give you a task, write a function that removes all duplicates in a data set, right? If you use the tools smartly, I introduce here to you, right? The introduction is very quickly. It's one after the other after the other. But that's why we have the practice for, right? So be aware what we try to do here, and that every task I give you can be done in like a few lines, right? And it can be quite easy. So you don't have to write some complicated code, usually. If you take what I give you as task and put it directly into Google, right? You come to some website and we see some more complicated stuff maybe. Okay? So whatever you do, first try yourself and then maybe Google. Right? Okay, and what I expect is it's, or others said, there's a hard solution and there's a smart solution. What you choose is up to you. Okay, do you know what's a tuple? A tuple is basically well, similar to a list or a set, just that once the values are given, we cannot change them anymore. So how do we use this? In a way, we would use tuples to define unchangeable constants, like gravitational acceleration, like mass of an electron. Do you know what is the G value here on this planet? Something like this here, right? 2.98 meter over square seconds. If you are coding nicely, you would put the units as a comment after the function definition. What else? So we could execute this, right? But then the next person can come and say G is some value of 1. Overwrite everything. If you run your simulation or calculation after this, all your results will be messy. And the moment your rocket launches and tries to land, it will crash, okay? Because somebody put a wrong value for G. It happens, right? So what you do is you want to protect this value, that whatever's happening in your program, nobody is changing anymore. So you define it as a tuple. G, right. And if we ask what is G at this value and we want to change this, right, this is how we do it. So we cannot change the value stored in G as a tuple like this. Right? Tuple object does not support assignment. However, we can override G. So you still need to be careful, okay? So this is different from this. Okay. Right, so these are our vector functions. There's one more. That is the range function. So the range function creates an iterator. You know what's an iterator, right? Something that runs over your iterations. So if, let's say you go from Monday to Friday to school, university, then Monday to Friday is your iterator, right? The date changes, but you still come here. The date changes, you still come here. You repeat this over and over again to improve your understanding and knowledge of science and technology. Yes, you do. So the general function definition of range can have three arguments: the start, the stop, and the step size. Let's see what we do here. So we define, for example, Z as range 120 to 3. So when we ask what is that, it's the same as we had before. This is not very useful, right? So we convert Z into a list. Then we get 147 because these are the values between 1 and 20 in step sizes of 3. Let's see what happens if we only have 20 here. If we only put 20, we get the values between 0 and, well, one step before 20. This is 19. You could check the length of this list with len, and we get 20. So far, so good. We can define a start here. Let's say 13. That gives me 7 elements because I start counting at 13 until 19, right? 1 before 20. Good. What happens if my start is larger than my stop? 24 to 20. Oh, nothing. Because the step size is taken as 1. How about I put a -1 here? Oh, it works again. So far, so good. So you standard count larger, right? If somebody tells you, I'm out of examples now, right? But if you count from 24 to 20 with increments of 1, that doesn't work, right? Because the next step is 25, and that stops there. But if you say you count backwards, okay. What else can we do? We can actually reverse this as well and bring it back into original order. We need to make it a list again. This is just so far so good. So what happens now is I made something very simple, very complicated, just to show you the differences between the range function. Right? Applying the range function to a list function, playing around with start, stop, and the step sizes, going backwards again, right? If I go backwards, I can reorder everything by reversing it. So I go forward again, but that is just in the factory function, so I must put it through a list to get a list back. So far, so good. You can also make it simple again, say you want to go from 20 to 24, step size 1, then you can skip all of this, reversing and relisting. Sorry, execute, and you're back at the original. Okay? We convert Z to a tuple file, we convert Z to a set, and please take note of the different brackets again. Right? So brackets really indicate here what kind of data structure, what kind of sequence we actually have. Okay, conditional statements. So it's time to make decisions. So shall I go to class today or not? If it is raining, I don't. If it is sunny, I try very hard. Good. So the keywords we have to look on are if and else. And well, there's an else between the if and the else, that is the else if. The if it is raining, I stay at home, else I go to school. Right? But you can have a second condition there, right? If it is raining, I stay at home. If else, right? If the bus is driving, I take the bus, else I take my scooter. Okay, so if keyword initiates a conditional code block. Right, so it's a code block, so we need to work with some indentations again and some colon. Elif and else further specify decision making. Elif is else plus if. We can separate different choices, right? And the choices normally must be translated in some form of a Boolean expression, right? Something must be true or false. So here's a small diagram how this goes. We normally have an input. Based on the input, we define a condition testing. And if the condition is true, right, we follow the if block. If it's not true, we go to no. So this really directs a program flow. So the general syntax, the most simple one is if condition expression. So let's have a on the fly example. If true, so the thing is true is always true, right? So the condition is 100% true. Print it's sunny. Okay. Now let's have a variable. So when I say a underscore I equal 1, and I test this, what do I get? When I execute this code now, what do I get? Well, we said everything but 0 is true as a Boolean type, right? So this one will be true as well. But remember my bool factory function, I put in 0, I get false, everything else got like true. But a1 has a value, so that will be true, and therefore I go into the block. If this one is 0, then nothing happens because it's untrue. So if it's untrue, I go into my else block. Rain. So far, so good. Okay, let's play more. NR equals 1 and J equals 2.0. So we could have now a condition that we return NR plus NJ, and over here we return NI minus NJ. Oops. Right. Obviously we don't have a function, so we must stick to print. Okay, so here -1. Let's do L if type NI equals type int. There's, by the way, a better form of checking the type than this one, but well, it's working, right? So now we check the value of AI. It's 0, so false. Therefore, we go to the elif block. Then we check the type of ni, which should be an integer. But ni is an integer, so we print its range and the difference between 1 and -2. Elsewise, we print nothing to do here. So we can check the type, for example, instead of ni for nj, which is float, right? And then we skip the elif block and we go to the else block. So far, so good. I'm using print here, right? But this is just to show you the program flow. In a real coding task, you would write a function and then return your result. Just to make this very quickly. So the non buckets I can just leave. I need to call the function. Okay. I can change within the function itself. Now I do not need to pass any arguments to the function because the variables are globally defined. Well, not really globally because in principle I can say global variable as well. That's not today. Not today global. Good. Okay. So what else do we have here? We have two other examples, two variables setting true, false, right? And if Boolean variable 1 is true, we print this is true. If Boolean variable 2 is also true, we print, oh, this is also true. But Boolean variable 2 is false, and change this. Okay, and we execute both if statements because they are in sequence. It would be different if we change this to an elif, right? Because this code block is only executed if the if block is false. That's elif. So we can do this. Right, so this is also true, and there's now the elif block, or we can have an else here, that we don't care about the value of b2, bv2 anymore. If it's true or false, that block, or this will be executed if the if block is false, or the condition to the if block is false. So far, so good. Another example. Condition is not defined. Execute looks like this. So the condition is false, right? So we skip the if block, we go into the else block, and we will print, or I enter the else block. It's right here. The value of value 2 will be stored in A. So value 2 is 0. So A will be 0. Then we print the value of A, which is 0. Very good. But now we also print I'm done with if and else, because the indentation for if and else, they end right here at line 13. After line 13, we are back to the main part of this code block, right, and everything gets executed. Okay. So, so as you have seen, the general syntax for the if and else block is if condition, then followed by expression, else another expression. So example common if statements. Let's see. So in this example, it looks a little bit funny, right? Because normally the indentation is at the same part, but because the colon indicates different code blocks and the indentation only must be consistent within the same code block, we could have here any amount of indentations. Still works. What we cannot do is mixing different levels of indentation within the same code block. Good. Inline if. So sometimes the if statements can be very compact. Right? If a number is bigger than the other, then do this, otherwise do that. So instead of having 3 or 4 or 5 lines of code, we put everything into one. Makes your code more compact. It's supposed to be easier to read. And the way we call this is called inline if statement. So inline might be a short form for in one line, right? We read it like this, but it's inline. What do we have? We have a value that is stored through evaluation of an expression, followed by if condition, else we have another expression. So let's see, does this work? So we have round brackets, right? Then expression, print hi, if true, else print by. Okay, so what will happen? Hi, right? Because true is always true. Now if I change true to false, right, the condition is not fulfilled because it's false. So I print by. Okay. So I also can put now in expression some values like 0 and 1. Define, I would call it a Boolean switch. Let's say, okay, go this direction in my program or that direction. I would set it to true, put this condition into the conditional block of the inline if, and store the value in my variable. Let's call it ji equal, sorry, like this. B switch into kind. Okay. So I got my result. That's not what I want. And then I can check what is ji, right? Getting some value. Okay. The expression can be more complicated. I can call a function, right? I can set some other fancy stuff here as well. Can be long, but in inline F, you want to have something quick, something short. So if it's becoming too long, then you skip it. Like a proper if-else block out of it. Okay, so some examples. Okay, so the general syntax about if and else we discussed already. Here's an example, if and else. But we have 1 minute left until the break, so how about we stop over here at the inline? Comments, questions? Do you want a break? Okay, 10 minutes, right?